So here's a homogeneous plate, and it's got things going on. It's a three-dimensional type of analysis. So we draw the free body diagram. We get this kind of diagram, and we have the three force equations right here. Um, let's see, looking at, yeah. So it's got a weight mass of 100 kilograms. So that's 981 newtons of gravity acting on it. And it has, what is it at B? Ball and socket at B. So it can have three forces in all three directions. Okay. BX, BY, and BZ. C, you'll have a vertical force. Let's see. A roller at A, which means only a vertical force. Ball and socket at B, and a cord at C. Okay. And that ought to give us everything we need to know. So counting up our reactions, one, two, three, four, five unknowns. Okay. Oops. There we go. Now, it's something to notice when it comes to force equilibrium is that several forces are up and down. These are the forces that are up and down. 1, 2, 3, 4. There's no other forces acting in the planar direction. So these two have to equal 0 right off the bat. BX and BY. BX and BY are 0 right off the bat. And then AZ plus TZ minus 300 minus 981 plus BZ. There we go. Has to equal 0. To get these three forces, then we have to use the moment equation. Moment around the x-axis. That's moment around this axis right here. So these two forces will not contribute to the moment. This moment will not. This is applied moment around the y-axis. And the BX and the BY will create a moment. Yeah, it'll create only BZ will create a moment. BZ, weight, and TC will create a moment around the x-axis. Because BY intersects the x-axis and BX is parallel to the x-axis. Okay. So mx TC times 2 meters. That's the moment due to this force right here. Uh, 981 times 1 meter. There it is. Here's the 981 times 1 meter. That's this force right here. This is going to be tending to make, this will be a positive moment, this will be a negative moment. And I should have, one more force is going to contribute to the x-axis moment, and that's BZ, which is going to tend to be a positive quantity. TC and BZ are positives, the 981 is negative. Okay, let's take a look, see if we got the right equations. Yep, right there. Thinking about the moment about the y-axis, we're going to have the applied moment, 200. I'm going to clear things out a bit, by the way. Okay. Okay. So around the y-axis, 200 Newton meters, negative 200 Newton meters, because it's going in the negative y direction. We don't have to worry about TC. These two are going to contribute. So that would be 981 plus 300, or 1281 times 1.5. And that would be in the positive y. So 981, 300 times 1.5 in the positive y direction. And then you'd have AZ and BZ contributing to y-axis moments. And both of those would be acting at 3 meters distant. So AZ, BZ, these two forces here. This intersects the y-axis, and this is parallel to the y-axis. So BX and BY do not contribute to the moment about y. So we just take all the terms that I've checked. There it is, BZ times 3, BAZ times 3, 200 Newton meters, 981 at 1.5 meters, and 300 at 1.5 meters. Okay, and now it's just a matter of solving the equations. I'm going to go ahead and set that up in a spreadsheet. Okay, we're ready to pick this up again. So first equation, coefficient of AZ is 1. Second equation, coefficient of AZ 0. Third equation, coefficient of AZ is, I'm going to go AZ plus BZ equals 300 times 1.5, 981 times 1.5 minus 200. So the coefficient would be 3. 103 for the coefficient of A. Now I set up a matrix. Here's the 103. So I'm using my linear algebra that I have some unknown vector. That vector x here represents AZ, BZ, TC. First element AZ, second element BZ, third element TC. This is a MATLAB lookalike program. It's called New Octave. Okay. Coefficient of BZ, 1 in this equation, 2 and 3. 1, 2, 3. 1, 2, 3. Coefficient of TC, 1, 2, 0. 1, 2, 0. So that's my matrix. What does it equal? First equation, it's going to equal 300 plus 981. When I add 1281 to both sides, you'll get 1281 equals AZ plus BZ plus TC. So that's what we enter in MATLAB or New Octave. 1281. Second equation would have to equal, for the same reason, we're going to move this to the other side of the equation, 981. There it is, 981. And for the third equation, since, this equation, not this stuff down here yet, I'm going to have to sum up this stuff right here. Since I'm moving this to the other side of the equation, it's just 1281 times 1.5 minus 200. And I can write that in as a formula in MATLAB or New Octave. So then that's what these three equations times that vector will equal this. And to find what that vector is, x, that's AZ, BZ, TC, you just do the division. Matrix goes into the A vector. This command right here. So this is how you solve simultaneous equations in MATLAB. 791, 217, negative, and 707. 791, 217, negative, and 707. Okay, this one we'll pick up later.